Now we're going to look at a story problem called baseball toss. This is the kind of problem that oftentimes when students first look at it, they think it's actually going to be very difficult, but in truth, it's one of the easiest story problems you will have. So I'm looking in section 2.3, and I'm looking at number 59. So this is going to be a story problem involving a quadratic equation. Let me just read from the book, once again, section 2.3, problem 59, called baseball toss. A baseball is thrown straight upward with an initial speed of 64 feet per second. Now let me just stop right there. Most of the time, whenever you have a story problem to solve, everything they tell you in the problem, especially if they give you some kind of a number, they give you that number because somewhere you have to use that in the problem. Well, this problem is one of those exceptions, because that first statement, they give you a velocity of 60, or initial speed of 64 feet per second. That's like a red herring. That number actually means nothing, and we are not going to use that number in any way to solve this problem. So until you do problems like this, you don't realize it, but that number is just thrown out there, but it means nothing. So let me read this again. A baseball is thrown straight upward with an initial speed of 64 feet per second. The number of feet s above the ground after t seconds is given by the equation s equals negative 16t squared plus 64t. And now there are two questions. Part A says, when will the baseball be 48 feet above the ground? And part B, when will it hit the ground? So let's talk about what we have going on here. A baseball, let me draw a picture. A baseball, here's the ground. A baseball is being thrown up in the air. And then, of course, after a while, gravity takes over and the ball falls down to the ground. Now here, we're looking at two things. We're looking at the height of the baseball, and we're looking at how much time has elapsed or passed since the ball was thrown in the air. So let me write it here. S equals the height of the ball in the air. And that's going to be like in feet. And then T is the elapsed time, or all right, time elapsed. And that's going to be in seconds. All right, so that is what we have going on here. Now let me explain. It's almost like, if you think about it, in this picture, this is like the S. This is the height of the ball. When the ball is on the ground, what's the height? It would be 0. And then it goes up here, it reaches some maximum height, and then it falls again back to 0. And all the while, the ball is in the air, the clock is ticking. Now here's why I say this is actually one of the easiest story problems you have to solve. Most of the time, the difficulty with story problems is you have to come up with an equation to help you solve the problem. Usually a story problem is a paragraph or a bunch of words with some numbers, and then they ask you a question. And then your job is to take all the information, the words and the numbers, and to come up with some equation you can solve. Well, you know what they do for this problem? They don't make you figure out the equation. They actually give you the equation. They say the height of the ball, S, equals negative 16t squared plus 64t. This is an equation that gives you the relationship between the height of the ball and the amount of time that has passed. Now, just so we understand this, let's see what happens. Say I ask you the question, well, what's the height of the ball when the time is 0 seconds? That means I would plug in 0 for t into this equation, and whatever that would equal, that's s. And in this case, the s would be 0 feet. Okay, well that makes sense, right? Because the ball, at time 0, the ball's on the ground. But just for fun, what if I say, well, please tell me the height of the ball after 1 second? How do I determine that? I go to my equation and I plug in 1 for t and I do the math. And in this case, if I'm careful in my head, I believe S would be 48 feet. So that says after the ball is thrown in the air for 1 second, the height of the ball is 48 feet. All right, so hopefully you understand what's going on here now. And once again, the key thing is they give you this equation. In most story problems, you have to spend time and effort to figure out the equation. In this case, they give it to you. Now let's see what they're asking us. In part A, they say, when will the baseball be 48 feet above the ground? Well, unfortunately, you can ignore my numbers here because I've sort of given you the answer. But let's assume we didn't do this right here, and let's actually solve the problem assuming we did not know the answer. So they're saying when the height of the ball is 48 feet, what will the time be? In other words, they're asking how much time does it take for the ball to get to 48 feet? How would we do that? Well, we would take our equation, and I'm going to set s equal to 48 and then solve for t. So I plug in 48 for s, then I have minus 16t squared plus 64t. And here is a quadratic equation with one variable t, which I need to solve for. So now it becomes a math problem. And the way we solve a quadratic equation is, well, one of the ways is maybe it'll factor. So let's go ahead, and I notice here, I have this minus 16 in front of my t squared, which I don't really want. I want it to be positive. So I'm going to move everything to the left-hand side. So I'm going to add 16t squared and subtract 64t. And after I do that, I end up with this equation, 16t squared minus 64t plus 48. So now I have this equation. I'm going to go ahead and see if it'll factor. Maybe it'll factor. So I think if I look, I think there is a GCF, and I think it's going to be 16, which would be nice. So I believe I can factor out a 16, and I get t squared minus 4t plus 3 equals 0. Now this 16 in front doesn't really affect my solution. Matter of fact, if you wanted to, I could just divide both sides by 16 and it goes away. But the key thing is now the trinomial in the parentheses. I need to try and solve that. Now I look, it's a trinomial, and I want to use my product sum. So I say my product is going to be 3, and my sum is negative 4. And then you realize, looks like it would be minus 3 and minus 1. So t minus 3 times t minus 1 equals 0. And now if I solve it for the first parenthesis, I get t equals 3 seconds. And for the second parenthesis, I would have t equals 1 second. So there are actually 2 times where the ball is at 48 feet. Does that make sense? Well, yeah, it does. If I go back to my picture, maybe 48 feet is right here. So you know what? The ball starts flying, and right here, it takes 1 second to get to 48 feet, and then it keeps going up, but now it starts to come back down again, and you know what? At this point right here, the ball is once again at 48 feet, then it hits the ground. So this is at 1 second, and this is at 3 seconds. So this answer makes sense. Now part B says, when will it hit the ground? All right, so we go back to our equation, and now we're going to set x equal to 0. So this is part A. Part B, when will it hit the ground? Well, what is s when the ball is on the ground? S would be 0. So let's go ahead and plug in 0 into my equation, and I have 0 equals negative 16t squared plus 64t. And now I have to solve this equation. Now I have actually a binomial, and there is a GCF. I'm going to go ahead and factor out a negative 16t. So inside the parentheses, I would have t minus 4. And now to solve for this, t would be 0 seconds from this t right here. And then from the parentheses, you would have 4 seconds. Now, does this make sense? Once again, they're asking me at what time is the ball on the ground. Well, it makes sense. The ball is going to be on the ground at 0 seconds before you start. So this basically says, after 4 seconds, the ball hits the ground again. So when this ball is thrown in the air, it takes 4 seconds for the ball to come down, and that's the amount of time it hits the ground. So these kinds of story problems, usually it's throwing balls in the air or maybe shooting a rocket in the air. At first they look sort of confusing, but they're actually very easy because they give you the equation. And then you just have to plug in the numbers.